you to find an inequality that has these solutions. And you made a good start by drawing the number line. You're correct, -4 is a 0. The inequality is undefined at those 4 points, -1, 5, 7, 9, but it's true in between those points. So because it's true at a single point, it must either be greater than equal to 0 or less than or equal to 0. So let's just write a function. This is what we're trying to find, the function, of course. Let's write it down as f of x. And let's just say greater than or equal to 0. I think you could probably do less than or equal to 0 and get a result. That's why there's, in other words, there's probably more than one inequality. But let's just make it greater than or equal to 0. And let's draw a function over here on this coordinate system that would satisfy this inequality. So it's true at -4, but not to the left or right of -4 up until -1. So it must be negative, and it must come up, touch the x-axis, come back down, and go up through -1, down through 5, up through 7, and down through 9. So if the function looks like this, it'll satisfy, it'll produce the solutions that we want, but it has to be undefined at these points. So these factors are going to be in the denominator. And the x plus 4 factor is going to be in the numerator. And it's going to be a situation where the function touches the x-axis but does not change sign. So it must be an even multiplicity. So let's square it. But we're going to want it to be negative just before and just after -4. So it's probably going to have a minus sign in front of it. And we'll see if that's true here in a minute, but you'll see. And the other factors must be x plus 1, x minus 5, x minus 7, and x minus 9. So let's just see if this function satisfies or has all the features we want it to have. So let's do a sign chart, and let's just look at everything less than -1. If x is less than -1, of course the numerator is going to be negative because we put that minus sign there. And all of the factors in the denominator are going to be negative, right? So we've got an odd number of negatives, so the function is negative up until -1. And then it's undefined at -1. And then in between -1 and 5, again, the numerator is going to be negative. The first factor in the denominator is going to be positive. And the next 3 factors are all negative. So we have overall an even number of negatives, so the function is positive in that interval. That's what we want. Just draw an arrow here. Then for this interval between 5 and 7, what happens? Numerator is negative. The first 2 factors in the denominator are positive, but the next 2 are negative. And so overall we have an odd number of negatives, and the function is negative, just like we want. Between 7 and 9, the sign chart looks like this, plus, 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 and then the last factor in the denominator is negative. Even number of negatives, the function is positive. Perfect. And then the end behavior, as x goes to infinity, it's all going to be, these are all going to be, numerator is negative, and all the factors in the denominator are positive, so we have a negative function. So this would be the answer.